Welcome back, guys. In this lecture, we are going to talk about one of the most complex topics, or we can say the topic which most of the beginners find difficult to understand. Okay, and that is closures. So, closures is one of the topics in JavaScript. If you ask anybody, they will say, like, this is the topic which I don't understand completely, right? But I believe with the correct explanation, with the right explanation, you can understand this topic way better than rest of the developers. Okay? And I believe with the knowledge you already have so far, like for scope chaining, variable environment, and the call stack, you can learn this topic way better. Okay? Because closures bring all these topics together. Okay? So now let's get into it. So, what we have to do, we first have to create a function to see how the closure works. Okay, so let's create a function quickly. So I'll use this function name as bookseat.js. So I'll be using the theme of the previous lectures like coding school. So here what I'll do, I'll basically create a function which will book a seat for particular JS course for the students. So students will come and book their seats for JavaScript course. Okay. So let's create a function quickly. And here in this function I will create a variable, or we can say a counter variable. Okay, students count I'll use, and then let's set it to 0. Okay, and now what I will do, I will return a function here. Okay, I'll return a function. What this return function will do, it will basically increment the count of this variable. Okay, so let's increment it by 1 every time we call it, and then simply log some text here. Okay, let's say total students count book their seats. Okay, so let's format it quickly. Yeah, now what I will do, I will store this particular thing, this particular function which we are returning from this in a separate variable, which I will call book now, and everything will start making sense when I'll explain all this. Okay, so don't worry. Now what I want this function to do is I will be calling this function here, so that whatever this function is returning will get stored into this one. Okay, so here right now in this function we are returning this particular function, right? That means this particular variable is now a function which is this function. Okay, and we have already discussed about this in one of the previous lectures, like how this variable will become a function when we are returning something out of it. Okay, so I don't think like I have to repeat myself again on that, right? And yeah, before explaining closures, I wanted to tell you one more thing, guys. So closures is not one of the things like which we can implement by ourselves. So let's say the way you can create an array, an object, or any other thing which you can create by yourself. So closure is not like that. Closures is something which happens automatically. Okay, so what you have to do is you just have to find the scenarios where you have to see like how the closure is working in it, because it will work on certain scenarios and you have to recognize those scenarios. So that is why we have created this function to create such a scenario. Okay, With this, we have created one scenario where the closure will work automatically. Okay, and we are going to analyze how closure works. Okay, so yeah, now we have written this piece of code where we are calling this function. This function will return a new function which we are storing into this function, this particular variable. And now let's understand what we have written so far with whatever knowledge we have so far. Okay. Okay, yeah. So now this is the function which we have written exactly in the code. So before this function gets executed, a global execution context will get created in the call stack. Okay. So now in global execution context, we will have the book seat.js which will be stored as a function. Okay. Because we haven't executed this. That means there will be a scope, a global scope, which will have book seat.js function itself. Yeah. So now this book seat.js function will get executed. And you guessed it right, a new execution context for the book seat.js function will get created, which will have students count in its variable environment. Okay, which will be initially set to 0 as we have already done. Okay, so now since this students count is 0, this is what we are going to get in the execution context as well. Okay, and in the scope chain, this is how it is going to look. So as you can see in the scope chain, we have this book seat.js scope where in the variable environment it have the students count. Okay, but wait, we also can see like we have this book seat.js function, right? This variable environment. That means this book seat.js scope can also access the parents variable environment, right? So right now this book seat.js is defined or written in a global scope. That means it can access all the variables which are defined in the global scope. Okay, so that is why it can access all the variables or all the variable environments of its parent scope. Okay, or we can say in simple words of its outer scope, right? So now after calling this function, as you can see, it is returning a new function. Okay, so this whole piece of code will get stored into this particular book now variable. Okay, so that means in execution context, in the global execution context, we have another variable or we have some other data in the variable environment of the global execution context which we can access in the book seat.js as well. As you can see, this can access the book now as well as book seat.js, and in the global execution context we will have the access or the data of the variables which we have declared here. Okay, so now what will happen? You have guessed it right. Since we have returned this particular function, the execution context for this book seat.js will get popped off the stack. Okay, and this is what we have to understand with the knowledge we have so far, right? Because we haven't seen how the closure works, right? So we can't discuss it right now. So that is the next step which we are going to discuss, but before that we have to go back to our code. Okay, so yeah, so whatever we have done, we have wrote a function, a global execution context will get created, and if the global execution context is getting created, obviously there will be a global scope, and in global scope, since we have wrote functions, so those functions will be available in the global scope as well as the execution context. And then we are calling this book seat.js function. That means a new execution context for this particular function will get created. For that we will have the scope, book seat.js scope. Okay, So that will contain the students variable which is written inside book seed.js, and it can access the variable environment of its outer scope, that is the global scope. That is why it is able to access the variable environment of the global scope, right? And then we have returned this function. So the execution context of this particular function is getting popped off. Okay, so now let's try to understand how the closure actually works. Now that we understand how our book now function is created, it's time to call this function multiple times to see what we are getting in the console log. Okay, so let's call it quickly, and we don't have to pass anything in the parameters since we are not passing anything here, right? So I've called it once here, and then let's call it multiple times, and then let's see what happens. So now as you can see, we already started getting the value which is getting incremented here, right? This student counts which is getting incremented. But if you think for a moment, from the previous slides, we have already seen that the book seed function, after calling it here, its execution context got popped off the stack, right? That means it have returned this function which is stored in this one, and then its execution context got popped off the stack. That means this bookseed.js function is no more in the call stack, right? But then how this student count variable is getting incremented? What I'm trying to say is how this book now function is able to get the previous value of the bookseed.js function's variable, and it is able to increment it. I think you already see it coming. This is because of something we are talking about from past few minutes, is closures, right? So we can say in simple words, um, the function which we create, like at the place where it is created, it remembers all the variables or the variable environments which were in the outer scope where the function was created, right? So that means this function, when it was getting created, it remembers all the variables, all the variable environments which were there in the outer scope or in the place where this function was created. So that is why it was able to remember the student count's initial value, and then it was able to increment it every time we call this function. Okay, and this is what we call the closures. So we can say this function have a closed over variable environment, right, which stores all the variables which were there at the time of this function's creation. Okay, so that if it wants to use those variables by any chance, it can use them. Okay, so this is how closures internally work. And now before I go and actually explain the closures, I want you guys to appreciate it, like how strange it is, how strangely it is working, right? Like that is the reason why it is so confusing for most of the developers. Because if you see, if you think logically, like this thing is already gone, and this variable which is not there but still we are able to access, right? That is why most of the people say this is happening magically. Now let's see what they mean by that magically word. Okay, so this is where we have left last time. Now we have called this book now function. So what will happen? A new execution context will get created. So as you can already see, this is now a function because this bookseed.js have returned a function which is this thing, and then we have called this book now, and On top of global execution context, a new execution context will get created. But the variable environment for this book now is empty. Okay, and since it is already in the global space, so the scope chain for this book now function will look something like this. Okay, but now you already start seeing a problem, how we can access the variable which is there in the bookseed.js, right? How we can access this variable and how we can increment it. So what will happen, like when you create a function, when you are returning it from some function, what happens is it will remember all the variables, all the arguments which were present in its outer scope at the time when that function was created. Okay, that means this function is now going to take the variables from its outer scope. Okay, or we can say from the global scope, right? So this time it is going to take that variable from the execution context of the bookseed.js, because this book now, or we can say this function, if you have a close look, it is getting created in the execution context of the bookseed.js function, right? That means this bookseed.js function is the outer scope for this particular function, right? So that means it will remember all the variables which were there in its outer scope. That is nothing but the bookseed.js function. So in the bookseed.js function, we have the student count, right? Apart from this, we have nothing else. So it will pick that student count and it will increment it every time. So initially the student count is 0, and then it will increment as we call the function, right? So as you can see right now, the booking scope is empty. It will get updated with the student count which we get from its parent scope. And why it works like this? It works this way because of something we already know, closures, right? So let me give you a formal definition of closures now. So it is something like a function always have access to the variable environment, or we can say VE in short form, of the execution context in which it was created, which I'm keep on saying like from the past few minutes, like this function was created in the variable environment or the execution context of the bookseed.js function, right? So it will always have access to all the variables, or we can say to the variable environment, so to say, of the bookseed.js function. That is why even after this function got returned, it is still able to access the students count. Okay, or in simple words we can say, like the variable environments gets attached to the function exactly at as it was at the time and place when the function was created. So what I mean by this, so basically the thing is, you wrote a function and you return a function, right? So this function is written inside this bookseed.js function. It will be like this function carries a suitcase which will store all the variables which were present in the execution context in which this particular function is created. Okay, so now it doesn't matter if this function is returned or it is still there, it will go and check its suitcase if the variables which it got from its parents execution context are there or not. Okay, and if it is there, then it is going to use that, and it looks at its suitcase, or it looks at it, we can say, like closed oval variable environment before looking at the scope chain itself. Because normally what happens, if you have written a variable in the parent scope and if you try to access it in the child scope, then the scope chain start working, right? it will look upwards. Like if it is not in current scope, then JavaScript will try to find it in the parent scope, right? But in this case, it will check in the closures first. It will check in the closed over variable environment first, which got attached to this particular function. Okay, and this happens before the scope chain. That means we can say closures have a priority over scope chain. JavaScript will look in the closures or the closed over variable environments first, which is attached to this function. Okay, and if that variable is not there, then only it is going to look into the scope chain. So I think you guys are clear, and if it still sounds confusing, then I have couple of more simpler definitions which will help you understand whatever I'm explaining here right now. Okay, so what basically happens is, like, we create a function, and then inside of which, if we are creating another function, then it will have a suitcase, right? Just understand this analogy. It will have a suitcase which will store all the variables, everything which is present in the execution context in which this particular function is getting created, right? So right now it is getting created inside of the bookseat.js function. So in the execution context of bookseat.js function, that means this function have a suitcase which have students counts in that suitcase, right? And then it carries that suitcase everywhere it goes. So if we are calling it multiple times, then it will check its suitcase to see like if the variable is there or not, and if it is there, then it makes use of that variable. So now let's see a working example of this. So we have called this function. Let's call this function now. We haven't run this function yet, right? So let's call this function for the first time. Then what will happen? This execution context we have already seen it got created, and then the student count will get incremented as we execute this function, right? As you can see, we have already there in the code, the student counts is getting incremented by 1 and the execution context will get popped off. Now we are calling this book now function again. That means a new execution context will get created, and then the student count will increment by 1 again. Okay, so previously it was 1. Since it have already a closed over variable environment attached to it, it will store the previous value of the student count. That is why this book now function is able to increment the value which it had earlier. Like it incremented it from 1 to 2. All because it have those variables stored in the closed over variable environment which this function carries every time we call this function. Okay, or we can say the suitcase which this function carries whenever it is called or whenever it goes anywhere. Okay, so now again, we have called this function, a new execution context got created and the student count got incremented. Okay, so now let's see a couple of more simpler definitions to understand the closures better. Okay, so the first thing we can say is a closure is a closed over variable environment, which we have already seen in the previous slide, which was there in the red color, right? Which was there in that red square. So a closure is a closed over variable environment of an execution context in which a function was created even after the execution context is popped off the call stack or gone from the call stack. That means that closed over variable environments will stay with our function forever. Whenever we call that function, that closed over variable environment will always be there with that function. Okay, and we have some more simpler definitions of it. We can say like A closure grants a function the access of all the variables of its parent function even after the parent function has returned, even after the parent function has gone completely. The function keeps the reference of its outer scope, which preserves the scope chain throughout the time. Okay. Now, if this one also sounds confusing, we have uh, another simpler definition. What we can say, a closure makes sure that the function does not lose connection to the variables that existed at the place where the function was created. So we have already seen in the previous slide or in the code as well, like our function, that book now function, it was actually getting created inside of the bookseed.js function, right? So its parent scope was that bookseed.js function. That was the place where that function is getting created, because out of that bookseed.js function, we have just declared a variable and we are just storing our function, right? So we can say a closure makes sure that function does not lose connection to the variables that existed at the place where the function was created. Or some people likes this analogy a lot. We can say a closure is like a suitcase which the function carries wherever it goes. Okay, this suitcase has all the variables that were present in the environment in which the function was created. So in our case, that environment is the book seed.js function, right? And that environment contains one variable, that is student counts. So now our book now function will have student counts variable in its suitcase. Okay. And yeah, and there is one more point. I think I've already touched upon this in the beginning of this lecture, that we do not have to manually create closures, or we cannot create closures manually. This is a JavaScript features that happens automatically, right? And all we need to do is we just need to analyze those scenarios where the closures are happening. And there is one more thing, we can't even access the closed over variable environments explicitly. The way we access the methods of an object or an array, we can't do that with closures. We can't go ahead and pick the closed over variable environments from the closures, right? Because closures is completely a non-tangible JavaScript object. It is an internal property. We can only see it happening under the hood. Okay, we cannot do anything with it. Or what we can do is we can check how the closure is working in the console log for a particular function, right? So let's see that right now in our code. So now we are back to our code. Let's see what is inside of the suitcase of this particular book now function. For this I will use console.dir. This is also like console log, but it is a little advanced, we can say. Okay, and now in this I will pass this book now without calling it. So as you can see, I have not used parenthesis. Now we are getting anonymous function in the logs, right? This thing. So if you expand this, we are getting length, name, prototype, argument, scholar. And this thing we have already seen in one of the previous lectures. Now if you are seeing this scopes, what does this mean? So this is the variable environment of this particular function. Okay, so that is why it is called scopes, and it is in the double square brackets. That means it is an internal property of JavaScript that we cannot access from our code. Okay, so now if we expand this, right after expanding this, we can see the closure. We can see the suitcase which this book now function carries all the time, and because of which our closures or the student count variable is getting incremented every time. Okay, so if you expand this, you can see the closure is coming from the book seed.js function. Since this is the parent function, or this is the environment where this function is getting created, that is why this function is closed over variable environment. This whole thing got attached to this particular function. So this function have the suitcase which contains everything this parent function has. Okay, so this function have a suitcase where we have this variable right now, because this is the only thing which we have in this bookseat function, right? And that is why here, as you can see, we are only getting this student count, which is now incremented to 4. Now if I call it only once, then let's see what happens. Okay, so total count is 1. If I expand these scopes again, the closures, as you can see, we have the student counts which have 1, because we have already incremented it. We have called this function now. What if I don't call it? And then let's see what will happen. Now we have the anonymous function in the scope. Now as you can see, it will have the student count with the initial value, which is this thing, this string right here, right? That means it have the variables, it have stored, or we can say it have the copy of this variable in its closures, or in its suitcase, or in its closed over variable environment. Okay, so this is how closure works behind the scenes.